All right, hi distance learning students. Today I'm going to show you how to use the data that I collected in order to do the experiment portion of Beekman's motor at home. So you're going to have an option. You can do an experiment where you increase the length of the wire loop, and I have 4 different levels of that variable. So there's a 0.5 meter loop, a 1 meter loop, a 1.5 meter loop, and a 2 meter loop. You can change the magnetic field if that's something you want to do. And I do 5 trials, each of 1 magnet, 2 magnets, 3 magnets, 4 magnets. And then I also have one of increasing voltage. So I start with 1.5 volts, I go to 3, I go to 4.5, and I go to 6. Again, 5 trials on each of those. So those are on the document that you have accessed at this point. And you can see right here the links to those. So let me just open this voltage one up. It's a folder. And it kind of has, the order is a little bit messed up. I'm going to change it so that it sorts by name. There we go. So you can see that I have 1, 2, 3, 4, 5 trials at 1.5 volts, 1, 2, 3, 4, 5 trials at 3 volts, 1, 2, 3, 4, 5 at 4.5, 1, 2, 3, 4, 5 at 6. All right. Now, what are we going to be looking at here? So let me open up, I'll open up the 6 volt trial 1. And this is a picture, this is a file that I recorded. And I did 20 of these. And this is the data. And just in case you don't remember, what I'm using is a voltmeter that's hooked up to Beekman's motor, and it's sending that to the computer. And every time there's a drop in that voltage, that is a spin. Okay. And you want to know how many spins per second do you have. Now, this particular one, there are a lot of gaps, okay? And then you can see where it's pretty consistent, then there are a few more gaps, and then it's pretty consistent. You don't have to look at this whole thing and count all the dips here, because what you want is you want to find, like, where is the data the most consistent? So I'm going to open this up, and I'll go from 2 to 2.5. All right, and so if I start at 2, the first peak is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it looks like there should be one there. I know that when I did this, it was constantly spinning. So there was a reading problem by the LabQuest. So I'm going to put one more in there, and that'll be 13. So that was 13 spins in half a second. So that would be 26 spins in a whole second. All right. Again, I'm not going to count all of these over the 3.5 seconds. I'm just going to find a place where it's more consistent. And some of the data is more consistent than other data. Most of it is pretty good though. Okay, but you're gonna look at every one of these files, and you're gonna make counts, and you're gonna enter that data. So let's talk about, and again, you're gonna see the same thing for the different ways of doing the lab. So how do I record and analyze this data? Well, if I'm going to record data, I need a data table, and then I analyze that usually by making a graph. So I'm going to show you how to do that. And when I make my data table, I can insert a table into a Google Doc, but I think a better thing to do is to open up I didn't want to do that. What I want to do is I want to open up a new document, and I'm going to open a spreadsheet. And I'm going to make my data table in there and my graph, and then I'm going to insert those into my document. So I'm going to open up a spreadsheet. And let's say that I want to know how the size of my wire loop, the diameter of my wire loop affects the spin rate, okay? Now, that's not one of your choices. Oh, come on. so I'm going to title that now. Here I'm going to put diameter. Then I've got spin rate trial 1. Spin rate trial 2. Spin rate trial 3. Spin rate trial 4. Spin rate trial 5, and then my average spin rate. And I'll do it for diameters of 0.5 meters, 1 meter, 1.5 meters, and 2 meters. Actually, you know what? I'm not going to put those meter symbols in there. I just want the program to recognize the numbers. And actually, since it's diameter, I'm going to make some fake data here. I'll say it's centimeters. All right, so this is my data table. Okay, and one thing I want is I'm going to figure out the averages. Now, you guys know how to figure out averages. You just add 5 numbers together and divide by 5. On Google Sheets, I can go, this will equal the average of B2 through F2. And I'll just hit return. It says I'm dividing by 0 because there's no data in there yet. I'm also going to copy and paste that into this column here. All right, so what I want to do is I want to go to data and I want to look at the spin rate. So I'm going to count those peaks like I just showed you. And let's say I count it, and for the first one I get 13, 15, 17, 14, and I don't know, 8. I'll just make it up. So notice it found the average, right? Okay, and then here it was 15, 16, 18, 20, and 14. Okay. And for this one, let's say, I don't know, 14, 18, 19, 20, 20. And this one, let's say it's 15, 15, 18, 17, 20. Okay. So I have a data table now, right? I want to make a graph of my data. I don't want to graph every trial though. I only want to graph the diameter and the spin rate. So what I'm going to do is I'm going to highlight these 2 columns. Oops. I'm going to highlight these 2 columns. I hold my command key down and I do that. I think on a Chromebook you might do it a different way. So sometimes when I highlight these 2 columns, it will just graph those 2 columns. We'll see if that works this time. And the answer is no. So this is not the kind of graph that is appropriate for this data. And I don't want to graph every piece of information that's on here. I just want the average versus the diameter. The diameter should be on the bottom since that's the independent variable. That's what you're changing or I'm changing. And this is the spin rate. That's what I want to graph on my y-axis. So first of all, I need to change this to a line graph. All right. I want to switch my rows and columns. So that was this one right here. See how that goes? It's not, that makes no sense. Spin rate should be on the y-axis. So I'm going to uncheck that. So here's my spin rate from 0 to 20. That makes sense. Here's my diameter, 0.51, 1.52. That makes sense. All right. I want to use row 1 as my headers. So I'm going to click that. And that tells me what I am graphing here. So there are 6 graphs, 1 for each trial and also 1 for the average. All I want is the average, this one right here. So I'm going to remove the rest of these. All right, and this is my average spin rate given by the data. So what happens here? Well, it looks like as I increase that loop diameter, it increases, but then as I increase more, the spin rate starts to decrease. Okay, so what do I want to do with this stuff? Well, I want to paste these into my document. So basically, I can just highlight that, do a copy. I would come to my document and paste that in. It says link to spreadsheet. I would say no. Let's paste unlinked. All right, and then I come back and I want to import this as well. So I click those three dots. I hit copy chart. I go back to my document here. Command V. I don't want to link it again. I'm just going to paste it. And there it is. Now, in your graph, you should have labels. You should say what these numbers are. There should be a title. There should be units there. So if I was to come here, I can title it. So I'm going to go to Customize and Chart and Access Titles. I would give my name, my title a chart, or my chart a title rather. And then I can name the x-axis. I can change my x-axis if I want. I can name my vertical axis too. Okay, so that is basically how to record and analyze data. Again, you're only going to be using data from one of these three links right here, because you're going to choose your independent variable as being either increasing voltage, increasing wire length, or increasing the number of magnets. And again, talk about how to include a data table, and then what you're going to graph, and then that is what's going to, lend information to your conclusion. All right, that's it.